Have you ever imagined teleporting to your favorite place in a blink of an eye? Teleportation, the concept of instantaneously moving from one location to another without physically traversing the space in between, has been a staple of human fascination for quite some time. It's a concept that has permeated our culture, popping up in everything from bedtime stories to blockbuster movies. We dream of stepping into a teleportation device in our living room and stepping out on a sun-kissed beach or a snow-capped mountain. Imagine being able to visit friends and family across the globe in seconds, or avoiding traffic to make it to work in the blink of an eye. The allure of teleportation lies in its promise to erase the boundaries that distance imposes on us. But is teleportation purely the stuff of imagination, or could it become a reality? As we delve deeper into this topic, we'll explore the possibilities and challenges that teleportation presents. Before we dive into the possibilities, it's important to understand what teleportation really is. This term might immediately conjure images of science fiction, with characters disappearing in one location and instantaneously reappearing in another. But what if I told you that this concept isn't as far-fetched as it seems? Teleportation, in the simplest terms, is the theoretical transfer of matter or energy from one point to another without traversing the physical space between them. It's like sending a letter from New York to London without the need for a plane or a ship. The letter just disappears from New York and reappears in London. This is what we mean when we talk about teleportation. But it's not just about moving things from point A to point B. It's about the exact reconstruction of the original object, down to the very last atom. Imagine you're teleporting an apple. It's not enough to get an apple at the other end. It has to be the exact same apple, with the same arrangement of atoms, the same taste, the same texture. Now, where does this concept come from? It's deeply rooted in our human desire for instant gratification and efficiency. We want to be able to move from place to place instantly, bypassing the limitations of time and distance. This is why teleportation has been a popular plot device in science fiction for decades. However, it's not just a product of our imagination. The concept of teleportation also has roots in the scientific world, particularly in the field of quantum mechanics. And while we're still far from teleporting humans like in the movies, scientists have already made significant progress in the teleportation of information at the quantum level. So, if teleportation is real, then how does it work? To answer that, we'll need to delve a little deeper into the world of quantum physics. But for now, let's just appreciate the sheer brilliance and potential of this concept. The idea of teleportation challenges our understanding of space, time, and the very nature of reality itself. The closest thing we have to teleportation in the real world comes from the field of quantum physics. Now, don't be alarmed. We're not about to dive into a complicated physics lecture. We're here to understand teleportation as it stands in the quantum realm. So what is quantum teleportation? It's a process where the state of a quantum particle, like a photon or an electron, is transferred from one location to another, without any physical movement of the particle itself. It's like whispering a secret in someone's ear across the room without anyone else hearing it or even seeing your lips move. Intriguing, isn't it? However, there's a catch. Quantum teleportation only applies to information. It doesn't mean that we can teleport physical objects like a cup of coffee or a spaceship, not yet at least. Here's how it works. Quantum teleportation is based on a phenomenon known as quantum entanglement. Quantum entanglement is a peculiar kind of relationship that can exist between quantum particles. When two particles are entangled, the state of one instantly influences the state of the other, no matter how far apart they are. It's like having a pair of magical dice, where no matter how far apart they are thrown, they always show the same face. In a quantum teleportation experiment, an entangled pair of particles is created. The state of a third particle is then teleported to one of the entangled pair, changing its state to match the original third particle. It's almost as if the third particle has teleported, but remember, it's just the information about its state that gets transferred, not the particle itself. This process doesn't defy the laws of physics, but it does boggle the mind. It's a real-world example of spooky action at a distance, a phrase famously used by Albert Einstein to describe the strange effects of quantum entanglement. Quantum teleportation is not about physical movement, but about instantaneous transfer of information. As of now, scientists have managed to teleport information across several kilometers using quantum teleportation. It's a fascinating achievement, but still a far cry from the teleportation we see in science fiction. But what if we could apply this concept to larger objects? Could we teleport humans? Well, the human body contains roughly 7 octillion atoms. That's a 7 followed by 27 zeros. To teleport a human, we would need to precisely measure and recreate the state of each of these atoms at the destination, a task that is currently far beyond our technological capabilities. So, while quantum teleportation is a remarkable scientific achievement, it's not the same as teleporting physical objects or people. But who knows what the future holds? After all, science is always full of surprises. The idea of teleporting humans is fascinating, but it presents a multitude of challenges. As we delve into the realm of teleporting humans, we're confronted by a labyrinth of scientific and philosophical conundrums that could make or break the feasibility of this futuristic concept. At the heart of these challenges is the Heisenberg uncertainty principle. This principle, named after the German physicist Werner Heisenberg, is a fundamental concept in quantum mechanics. It states that it's impossible to precisely measure both the position and momentum of a particle at the same time. This principle is a significant hurdle in teleportation. If we can't accurately measure these properties, how can we hope to replicate them perfectly at another location? This is like trying to paint a masterpiece without knowing the exact shades of color you're using. The second challenge is data storage and transmission. The amount of information in a human body is staggering. Every single cell in our body carries our DNA, a complex code made up of around 3 billion base pairs. If we were to convert this information into digital form, it would amount to approximately 1.5 gigabytes per cell. Multiply that by the trillions of cells in a human body, and you have a data storage problem of epic proportions. Even with our most advanced technology, storing and transmitting this amount of data is currently beyond our reach. And then there's the issue of originality. If we successfully teleport a human, the person at the other end wouldn't technically be the same person. They would be an exact copy, a clone, if you will. This raises profound philosophical questions about identity and selfhood. Would the teleported person still be you? Would the original need to be destroyed for the teleportation to be successful? And if so, would this amount to murder? Furthermore, what about the soul or consciousness? Does it get teleported too, or does it get left behind? These aren't just philosophical musings. They have real implications when it comes to the ethics and legality of teleportation. Finally, there's the small matter of the energy required. Teleporting even a small object would require a tremendous amount of energy, vastly more than we currently have at our disposal. Teleporting a human would require an astronomical amount of energy, which would have significant environmental implications. These challenges are daunting, certainly, but they aren't necessarily insurmountable. As we've seen throughout history, technological advancements often come in leaps and bounds, fueled by human ingenuity and determination. Despite these challenges, should we completely dismiss the possibility of teleportation? That, dear listeners, is a question for you to ponder. While teleporting humans might be beyond our reach now, the concept of teleportation can still have many other applications. Let's start with computing. Quantum computing, to be exact. In this field, teleportation is not merely a sci-fi concept, but a fascinating reality. Quantum teleportation, which involves the transfer of quantum information from one place to another without traversing the space between, is already a crucial aspect of quantum computing. This is because quantum teleportation allows quantum information to be transferred faster than light, making it possible to perform computations that would be impossible with classical computers. Now imagine if this technology could be applied to the field of communication. We could potentially achieve instantaneous data transmission over vast distances, bypassing the limitations of current technology. It could revolutionize how we communicate, making the world even more interconnected than it is today. But what about transportation? Could teleportation revolutionize this field as well? The answer is a resounding maybe. While the teleportation of humans or even large objects might be a far-off dream, it's possible that teleportation could be used in other ways. Consider the transport of goods, for instance. Imagine if we could teleport goods from the factory directly to the store, or even straight to your home. This could dramatically reduce the time it takes for goods to reach consumers, not to mention the potential environmental benefits of reducing transportation-related emissions. Or think about disaster relief. In the aftermath of a natural disaster, getting aid to those in need can be a logistical nightmare. Roads may be blocked, airports may be unusable, and time is always of the essence. But what if we could teleport supplies directly to the disaster zone? The impact could be life-saving. There's also the potential for teleportation in fields we might not immediately think of. For example, in healthcare, imagine if we could teleport medication directly into the body where it's needed most. Or in space exploration, what if we could teleport equipment or supplies to distant planets or space stations? Of course, all these applications come with their own set of challenges. The The technology required is currently beyond our grasp, and there are also ethical and safety considerations to take into account. But that doesn't mean we can't dream, and it doesn't mean we can't strive to make these dreams a reality. In the end, the potential applications of teleportation are as vast and varied as our imaginations. And while we might not be teleporting ourselves across the globe anytime soon, the concept of teleportation is already shaping our future in unexpected ways. So, is teleportation the future of travel? The answer might be more complicated than a simple yes or no. But one thing's for sure, when it comes to the potential of teleportation, we've barely scratched the surface. Teleportation is a concept that has sparked the imagination of many. It's a fantastical notion, plucked straight from the pages of science fiction novels and the silver screen. But as we've journeyed together in this exploration, we've seen that teleportation is not just a figment of our imagination, but a real phenomenon rooted in the principles of quantum physics. Let's quickly recap. We started with a definition of teleportation as the process of moving objects from one place to another instantaneously, without traversing the space in between. We then delved into the realm of quantum physics, the science of the very small, where teleportation is not only possible but has already been achieved with particles like photons. We also discussed the daunting challenges of teleporting larger, more complex entities like humans. The Heisenberg uncertainty principle tells us it's impossible to know both the position and momentum of a particle with absolute certainty. This makes the exact replication of a human, with our trillions upon trillions of particles, a monumental if not impossible task. We then moved on to the potential applications of teleportation. While human teleportation remains a distant dream, teleportation of information at the quantum level could revolutionize fields like computing and cryptography. Quantum teleportation could enable the creation of ultra-secure communication channels and super-fast quantum computers. Now let's ponder the societal and ethical implications of teleportation. If we could teleport, it would fundamentally change how we perceive distance and time. Our world would become a global village in the truest sense. But with this new power would come new questions. What about privacy, if we could potentially pop up anywhere, anytime? What about the economy, if physical goods could be transported instantaneously for almost no cost? And then there's the philosophical conundrum. If you teleport, is the person who arrives at the destination still you, or just an exact copy? Would you cease to exist in the process of teleportation? These are profound questions that we'd need to grapple with, should teleportation of complex beings ever become a reality. So, is teleportation the future of travel? At this point, it's still more science fiction than science fact. But the journey of discovery, the pursuit of the seemingly impossible, is what propels us forward as a species. It's how we've gone from horse-drawn carriages to rocket ships in just over a century. Whether or not teleportation becomes a reality, it will continue to fascinate us and push the boundaries of our understanding of the universe. And who knows? Maybe one day we'll be able to say, "Beam me up, Scotty," and actually mean it.